In this video, we're going to discuss the factors that will favor E2 reaction, as well as all the steps that are involved in an E2 mechanism. E2 stands for bimolecular elimination reaction. There are two components that are involved in an elimination reaction. One of them is the substrate that has an alkyl group attached to a leaving group, and the other one is the base. E2 is bimolecular because the rate of the reaction depends on both the concentration of the substrate and the concentration of the base. Then that makes E2 reaction a second-order reaction. Now let's look at the factors that will favor E2 reaction. There's no preference in terms of the substrate for E2. As for the base, it will want to have strong bases like hydroxide or alkoxide. We can use tert-butoxide, which is a bulky base, if we are competing against SN2. There's really no preference in terms of the solvent. For temperature, it's going to want to go for a higher temperature because higher temperature encourages elimination reaction. This is a key point if we're competing against nucleophilic substitution reaction. As for the stereochemistry, this is very important. The hydrogen that we're going to remove must be anti to the adjacent carbon that contains the leaving group. This type of arrangement is called anti-periplanar or anti-coplanar. It will be clearer when we look at the mechanism later. Note that E2 mechanism is going to happen in one step. That means the base will remove the proton and at the same time the leaving group is going to depart. In this example, we're going to work with S2-bromobutane as our substrate. The main requirement for E2 to take place is that the H to be removed must be anti to the carbon that's connected to the leaving group. That means the H, C, C, and Br must all be on the same plane. At the same time, H is anti to Br. Now, this may not be very obvious looking at the structure this way. So, if we were to draw out a Newman projection along carbon 2 and carbon 3, we can see that Br is going to be anti to the pink hydrogen. And that's what it meant by anti-periplanar. Another point to note is that if the substrate is a cyclohexane ring, aside from the H to be removed and leaving group being anti-periplanar, both of the bonds must also be axial, cannot be equatorial. Otherwise, E2 won't take place. This is another important point to note for a substituted cyclohexane. Hydroxide ion, which is our base, is going to remove the proton that is anti-periplanar to bromine. Electrons on CH will form CC double bond. At the same time, bromine will leave, which is evident in this transition state. We see the bond between base and proton forming, H and carbon breaking, C and C forming, and then C and Br breaking. So we see all these partial bonds in the transition state. The final product that we get is going to be trans-2-butene from this elimination example. We've just looked at the mechanism that produced the major product, which is trans-2-butene. There are other possible products that can be formed through E2 of S2-bromobutane. However, trans-2-butane is the major product because it's the most stable following Zaitsev rule. Can you figure out what are the other possible products? Do place your answer in the comments area. Let me know if you wish to have a video explaining formation of different elimination products as well as Zaitsev and Hofmann rule. I have other videos on SN1, SN2, and E1 mechanism. Do look for them in the description box below if you're interested. Here's a video that I've handpicked for you. Do check out our app that's available in both Google Play and App Store. Thanks for watching all the way to the end. If you find this video helpful, be sure to like and share it with someone. Don't forget to subscribe and hit that bell icon so you won't miss future videos. Your support means a lot to me.